They have not received theirs yet. All right, here you go. Let's do number 1. See if you can give that a shot now. I'll give you a few minutes. Ready, set, go. All right, let's see it. Take a look up here. Don't work on your assignments right now. Take a look up here. All right, in the system of equations above, A and B are constants. That's that guy and that guy. They're numbers that are just numbers. They're not variables. If the system has infinitely many solutions, then what would be the value of A? All right, so one of the things we've seen this before, right? What does that mean? What would that look like if you had an equation? Good. Same equations, right? In order to make that happen, if you used elimination, for example, you'd end up with 0 equals 0, right? So in order for that to be true, we would want these two equations to be the same. This one to be exactly the same as this one. All right, so one thing you could do is multiply the top by -5. So let's do that real quick. It would say -15s plus 10t equals -5a. That way, the s's are the same. Also, you could say that b has to be 10 if they asked for b, right? Because you'd want this side to be the same as this side. But they're not asking for b, they're asking for a, right? So since the left side we've now made the same, that means the right sides have to match up as well. Yeah? Okay, so if that's the case, think about what we're saying. We're saying this on the right side of the equation. We're saying -5a has to be the same thing as -7. -5a must equal -7. And you're trying to figure out what a is. So if that's true, we could divide by -5. What's a negative over a negative? Yep. And there's your answer. Remember on the SAT, how many negative answers are there if it's fill in the blank? 0. None. It's not even possible to fill it in the bubble, right? It's not even there. Yep. There you go. All right, so this is kind of review, and some of the stuff we're going to talk about today is a little bit of review from what we've done already. Yesterday, very briefly, we talked about slope, remember? Here's what that slide looked like. This is the second page. We've talked about this stuff already. If the lines are parallel, then there's no solution. If they're identical, then there's infinite solutions, right? And if it's not either one of those, then you have two lines that are intersecting at one point. You have one solution. The second thing, which was kind of new, and I had to really speed through, was this stuff right here. Parallel versus perpendicular lines. We already have seen parallel lines, right? They have the exact same slope. Two lines are perpendicular. If you take their slopes, you multiply them, and you get -1. And I kind of quizzed you real quick. They also have to be opposite reciprocals. So flipped upside down and opposite. That would make them perpendicular. What does perpendicular mean again? They intersect at a 90-degree angle. Yeah, it looks like that. So if I have a line like this, the other line do that, and they intersect at a 90-degree angle, right? That's what they look like. Now, give me an example here. Somebody give me a slope right now. Shout it out. 3/5. So if you had a line that had a slope of 3/5, if another line was parallel to that, what would the slope be? So parallel would be 3/5. What about perpendicular? Perpendicular. It would be the opposite and flipped. That's what the slope would have to be. right? It had to be opposite and flipped. Give me another slope right now. Give me a whole number. 4. Let's say the slope was 4. If it was parallel line, it would have a slope of 4. If it was perpendicular, it would be flipped upside down like that and made opposite, right? What if it started as negative? Then what would this be? Positive. Okay? So we're going to have a con assignment that has something to do with that today, a little bit. But before we get to that, let's do number 3 here, because this is your other con assignment today. All right. Take a second. Let's do that one. Here's number 3, real quick. What's the best interpretation of the number 65 in this equation? All right. So now we can kind of look back. 65 is right next to t. T is a variable, and t is a certain number of days. 65 times the days. And this is an equation of a line, right? There's no squared, there's no cube or anything like that. It's just something to the first power. So before I answer that question, can you tell me what this number means? Number of voters when?
Oh, that one.
That one, the highlighted one.
Sorry.
It's all right. Well, total when?
Beginning of the drive.
At the beginning, right? So at the start, before we're counting the number of days, that highlighted part, the 3,450, is where they started, right? The equation of a line has 2 parts, the y-intercept and the slope. The y-intercept is usually some kind of starting point, an initial amount if you're talking about dollars or something like that. But this one's what they're asking about here. What's 65? Well, that's the slope, isn't it? And slope is a rate of change. So it's how many something per something is what you should answer. The green one was A, right? B, the number of registered voters at the end of the registration. Nope. Total numbers registered during the drive. Nope. We need a rate. It says each day. This is the important phrase right there. So it's D, right? Let's take a look at the last one, number 4. I'll work this out with you right now. All right. So what value of A will result in a system with no solutions? Now, if you have a system with no solutions, you usually have some kind of thing like this at the end. Somebody give me a number. It'll look like that, right? Something like this, where it makes no sense. In order for this to happen, the variables have to be eliminated, right? So we have to use elimination and figure out what would A have to be if we're using elimination. All right, try it out. I'll give you about a minute. Ready, set, go. Kind of funky. It's not nice and neat because there's you're going to have to multiply by some kind of decimal, won't you? All right, what do you have to multiply by? Somebody tell me. Because you want to get rid of the variables, what would you multiply by? You want no solutions. Well, if you're using elimination, you're going to want the x's to disappear, right? So when we would do this and we said we want the x's to disappear, we would multiply by something that would turn that 2 into a 9. What do you have to multiply by? 4.5. Now, I'm going to do this. I'm going to use fractions, okay? You're not going to like it, but it'll be better off in the long run. Ugh, right? 4.5, isn't 9 over 2 the same thing? Yeah. All right, so when I do this and I distribute through there, here's the top still. This would then become negative 9. And then now that I turn this into plus 9 over 2a. And then this side, let's see, 6 times that would be, so 4.5. That would be 27. And then since we're using elimination, we would say, all right, these two add up to 0. And then what we'd want is these two to also add up to 0, right? So this is what we would want to happen. We would want 9 over 2a to be 14. We would want that chunk of stuff in the second equation, the yellow highlighted part, to be 14. So think about what I'm saying. 9 over 2a is supposed to be 14. And it's positive because I multiplied by a negative. You could have done it differently. If you said I wanted them to be the same, then your equation would look like this. And maybe you use 4.5. Maybe you did that. Either way, you're going to end up with a positive answer. All right, now how do you undo this? Well, you multiply by 2. And then you divide by 9. So your answer is really funky and nasty. Okay, but that's our answer. You could also get 3.1 repeating, right? If you had that as a decimal. Anybody get that? Blink twice if you got that. It's a tricky one. All right, now let's do some from your con assignments. Very quick. They're not too bad. What do the following two equations represent? Are they the same line? Are they perpendicular? Are they parallel? Or do they just intersect? Okay, if they're the same line, everything's going to be the same. If they're parallel, the slopes are the same. If they're perpendicular, opposite reciprocals. That's what we just talked about. If they're intersecting but not perpendicular, that would mean they have different slopes, but not opposite reciprocals. Right? So let's run through all those again. What if they're the same line? Exact same equation, right? Parallel lines. Same slope. This one, opposite reciprocals. Like if one of the slopes was 3, the other one would be positive 1 over 3, right? Intersecting but not perpendicular, they would just be two randomly different slopes. They're eventually going to touch each other. All right, so let's work through this. On this one here, we're going to have to move some stuff around. First thing would be to move this 6x over there. Then divide by negative 15. So divide by negative 15. Divide by negative 15. Make sure you reduce your fractions. So this is going to be negative 1. And then our slope is 6 over 15. You can reduce that. Divide them both by 3, right? 2/5. Yeah, awesome. 2/5 x. Take a look at this. Compare it to the second equation. Different order, except they're still the same thing. Did I mess something up? So we're here. I move the negative 6 over. That's negative, and then I divide it by negative 15. Yep. Hey, I messed up before. Don't be afraid to ask. All right. So anyway, these are the same line. Now I want to go through this. What would make them parallel? Well, a parallel version to this blue one would be the same slope, but then any other number, right? That would be a parallel line to that. What would make them perpendicular? We'd have to flip the slope and make it negative. And then any other number here, like that. What would make them intersecting but not perpendicular? Well, any other slope other than 2/5. Anything else. Something like that, whatever. Okay, another assignment is this one. How tall was the tree when Renata moved in? Take a look at the equation. Read it fast. We just mentioned it earlier, right? The slope is measuring some kind of rate. This is your slope. That would be how many centimeters per year. But that's not what we're asking this time. It says, how tall is the tree when they moved in? 210. That's your starting point. Right? Your y-intercept is your starting point. And last one for today. I got two more. I lied. It says, what's the temperature increase that is equivalent to a temperature increase of 10 degrees Celsius? So in other words, you'd have to say, plug a 10 in there for Celsius, right? And if you did that, it would take that 32 and it'd be adding 18 instead of 1.8. So it'd be 18. Easy enough. Last one is an SAT form right here. A line is graphed in the XY plane shown at left. Which of the following is an equation of that line? They have written it all sorts of kind of funky over here. It might help to change them. So let's move that over there and that over there. That would turn the equation into y equals negative x plus 1. This is a negative slope. Negatively sloped lines go that way, right? They go down. Okay. This one would be y equals negative x minus 1. Same thing. It would be a negatively sloped line. C. Let's just move the y over here. It's faster, right? It would say x plus 1 equals y. See that? This one has a positive slope, but the y-intercept is positive 1. It should be up here. So it's not A, it's not B, and it's not C. Let's circle D and be done with it, right? It is because if you move that y over, it would look like this. Y-intercept at negative 1 and a slope of 1. Up 1 over 1. All right, that's all for me today. Try those two out, and if you're done, do these three here. We're going to work some more on these tomorrow, and then quiz at the start of the week next week.